Now, the last one. A block with a mass m moves along an inclined plane that makes an angle theta with the horizontal. A constant force, F, x along the plane. The block was forced to a complete stop after time t. A. Neglecting the friction. Find the magnitude of the displacement along the incline, d1. So, what's the first step of doing this type of question? I forgot. Oh, good job, you remind me. It's a free body diagram. Good job. So, this represents the center of mass of the object. Of course, there's gravitational force acting on it, which is Fg. The normal force will always be perpendicular to the surface it is contacting with. This is a surface. This is the normal force. No friction force in the A part, so we don't need to worry about it. And there's the action force that is pulling it along the surface. This is the action force. F. So this is still a type of incline question. It looks terrible, but let's assume it is perpendicular. So let's see. So for the horizontal direction along the incline, there are two forces or two components of the forces. One of them is the action force, and the other one is the horizontal components of the Fg, and it is opposing the direction of this F. So we can write the net force equation. Net force Fx is equal to F. The bigger force always comes first because it is moving along the incline, right? The bigger force always comes first. F minus Fg. This is theta, by the way. Fg times sine theta. It is equal to ma. A. A. Okay, and then we can get A is equal to I'll make it look a little bit better. It would be F over M minus G sine theta. This is your acceleration along the slope, and then you want to find the displacement, right? After a time t. So x is equal to v naught squared plus half a t squared. Let's assume the block is also at rest initially. Yes, it is at rest at initial state, which x is just equal to half a t squared. So now let's just plug in the value. Plug in a directly to this expression. We can get x is equal to half times f over m minus g sine theta times t squared. I think it looks good, in my opinion. It already looks good, so I don't need to simplify it. Well, and then this is your answer. That's it. This is your displacement, the magnitude of displacement, actually. Now, the B part. With friction on the incline, coefficient of friction equals mu. First, find the magnitude of displacement along the incline, d2. 2. If the time is doubled, which means t is now equal to 2t, find the ratio of the new displacement d3 to d2. Assume the incline is long enough. Alright, let's begin. Oh, I forgot again. What's the first step of solving this problem? Yes, free body diagram. Good job. So, B part. I should move it a little bit to the right, to the left. Free body diagram. This represents the center of mass of the object. This is mg. I think you already realized that there's a normal force perpendicular to the surface, Fn. There's an action force, F, and there is a friction, which is opposing the direction of the object's moving. So this is F. And the magnitude of FF will be always smaller than the magnitude of the Fn. So now let's solve the question. First step we need to do is to break them down along the slope and the direction which is perpendicular to the slope. Oh, it looks terrible again, but I think let's assume it's perpendicular. I don't have a ruler besides me. So the block is moving upward, right? So we should do a net force equation for the horizontal components, which is net force F x is equal to F minus this component over here. This component is pointing that way, and FF. So we can write it down. Minus mg. Also, this is theta. Using trig, we can get this component, which is mg times sine theta minus ff is equal to ma. M times a2 actually. It is not. It is not. It has. It doesn't have the same acceleration as the last question. And then we can write a net force. We cannot figure out the ff yet because we don't know the normal force. So let's write the net force equation out for the vertical component as well. Net force Fy is equal to Fm minus, using trigonometry, mg times cosine theta. It's a block moving vertically upward or vertically downward relative to the slope. No, it's not, because it is moving along the slope. If you don't understand what this means, if you don't understand what I mean, moving vertically upward means that it's just like moving in that direction. It's like it's no longer have contact with a slope. So I think you understand what I mean. So this is equal to 0. We can easily get Fm is equal to mg cosine theta from this expression, and we can then easily get Ff is equal to mu times mg cosine theta. Now we already figured out Ff, so let's plug it back in to x direction. Net force Fx is equal to F minus mg times sine theta plus mu cosine theta. I just reformed it to make it look better, and it is equal to m times a2, which we can get a2 is equal to f over m minus g times sine theta plus mu cosine theta. What is the question asking you? Oh, it is asking for the displacement along the incline d2. So we can still use our kinematic equation. Wait, let me pull it a little bit downward. d2 will be just equal to v naught squared, v naught t, plus half a t squared. V naught is equal to 0, right? So d2 is simply equal to half a t squared. Let's plug the value in, which we can get d2 is equal to half f over m minus g times, let's write t squared over here, g times sine theta minus mu cosine theta. Mu cosine theta. And this is your answer for the first part of B. Now, if the time is doubled, find the ratio of the new displacement, d3 to d2. Assume the incline is long enough. This is actually free, because you already get the expression for the displacement along the incline of the object. So when the t is doubled, right, d3 will be equal to t, 2, t squared now became 2t squared, which is 2t squared times blah blah blah, times this long expressions. We don't need to care about this expression because there's nothing related to t. So d3. So now d3 will become 2t squared times this long expression, exactly the same. I'll just copy it down. So what is a numeral ratio between d3 and d2? This is simply d3 over d2. It's just equal to, I don't want to write it again, just 2t squared times, just 2t squared times this long expression over half t squared times exactly the same long expression, so that we can cancel these two out, right? Which will only become 2t squared. Wait, I should write it down. 2t squared over half t squared, which we can get the final answer 4.